Hi there. Example 73.6. Using the probability tree approach. So what's the question asking? Well, we've got an urn with 4 red marbles and 7 blue marbles, and we're drawing twice from this urn. And we'd like to know what are the chances we draw a red on our first draw and then draw a blue on our second draw. And we'll solve this problem in 2 different cases. One where the experiment involves replacement of our draws, and another where the experiment doesn't involve replacement of our draws. So, part A, we have replacement. We're going to draw a probability tree here. So one way of thinking of this is after our first draw, we either drew a red or we drew a blue. And what is the chance we drew a red? Well, there's 4 reds out of 11 in total, so the chance of drawing a red was 4 over 11. And what was the chance of drawing a blue? There's 7 blues and there's 11 in total, so 7 over 11. Now, we're interested in the chance of drawing a red and then a blue, which means we're not going to bother exploring this branch of the tree where we draw a blue first, because that's irrelevant. We're going to explore this branch where we draw a red first. So here we are, we just drew a red marble. We've replaced that red marble back into the urn. So there's now, in the urn, there's still 4 red marbles and 11 marbles in total. And 2 more things could happen. We could see it as this way. We either draw another red for our second draw, or we draw a blue for our second draw. So what was the chance we draw a red on the second draw, given that we drew a red on the first draw? Well, it doesn't matter that we drew a red on the first draw. The 2 draws are independent. The second draw doesn't depend on the first draw. So again, the chance is 4 over 11, and similarly, the chance of drawing a blue on the second draw is 7 over 11. Notice the second branch, the second branching is the exact same as the first branching. It's because the second event, it's the same as the first event. And it's also independent of the first event. Okay, so now, well, we're not really interested in the case where we drew a red on the second draw. We're interested in the case when we drew a blue on the second draw. So this is where we land. And what was this? This was we drew a red on the first draw and a blue on the second draw. And now we can calculate the probability of landing at red-blue by simply multiplying these together. 4 over 11 times 7 over 11, which gives us 28 over 121, which is, using a calculator, 23.1%. And there we have the probability of drawing a red on the first draw and a blue on the second draw is 23%, 23.1%, or 28 over 121. So we could have created the entire tree here, but we only needed to investigate the branches that we knew we were going to be following. Okay, part B. Now there's no replacement, which means the first draw will influence the second draw. In other words, the second draw will be different depending on if we traveled red or we traveled blue. So let's see how that works. So again, our first draw happens. We either drew a red or we drew a blue. If we drew a red, we'll go on from there. But what was the chance of drawing a red? Well, there's 4 reds in total, and there's 11 marbles in total, so 4 over 11, and similarly, chance of drawing a blue, 7 over 11. Okay, so we don't really care about traveling this path where we drew a blue on the first draw, because we're only interested in the chance of drawing a red on the first draw, followed by a blue on the second draw. So we travel along this path here. And now that we've drawn a red on the first draw, well, what could happen on the second draw is we could draw a red again, or we could draw a blue. So what's the chance we draw a red? Well, it's no longer 4 over 11. It's going to be, well, there's only 3 red marbles left, and there's only 10 marbles in total, because one of them is taken out already. So 3 over 10 is the chance of drawing a red on the second draw, given that we drew a red on the first draw. Now what's the chance of drawing a blue on the second draw, given that we drew a red on the first draw? Well, there's still 7 blue marbles in the urn, and there's 10 marbles in the urn in total, so 7 over 10. Okay, now, well, we're not really interested in traveling the red path on the second turn, because we know on the second turn we travel the blue path. And that lands us at RB, red first, blue second. Now, what's the chances that we land there? The chance that we land there is going to be the chance that we took red on the first try and then took blue on the second try. So that's multiplied, makes 28 over 110, which percent-wise, based on calculator, is 25.5%. And so there we have the probability of drawing a red first and then a blue second. So that's example 73.6. To really emphasize something, we're going to continue studying this, but just know that the question has been answered. Here's the probabilities that we're looking for part A and part B. But just to emphasize what an independent event is versus a dependent event, we're going to take a quick look at what would have happened if we finished these trees out. So we're going to finish each of these trees. So we'll start with replacement. So with replacement, again, after we draw a blue, there's 2 chances, red or blue, two choices. And what's the chance of drawing a red on the second draw? Well, remember there's replacement. So there's 4 red marbles in the urn, and there's 11 marbles in the urn in total. And what's the chance of drawing a blue on the second draw, given that we dropped blue on the first draw? Well, there's still 7 blues in the urn, and there's still 11 marbles in the urn. So here we have the this part of the tree finished out. Notice, now this is what independent events mean. The probabilities for the second branching are the same, no matter which of the first branches we took. So whether we took the red branch for the first path of the journey, or the blue branch of the first path of the journey, the second journeys still have the same chances. It didn't matter which path we took in the beginning. We're going to see that's different when we complete this tree out. So now we're in the experiment where there is no replacement, and we've imagined we've just drawn a blue marble. So again, there's two choices. We could draw a red, or we could draw a blue. And what's the chance of drawing a red on the second draw, given that we've drawn a blue on the first draw? Well, there's still 4 red marbles, but there's only 10 marbles left in the urn, so 4/10. And what's the chance of drawing a blue marble on the second draw, given that we've drawn a blue marble on the first draw? Well, there's only 6 blue marbles left because one of them has already been drawn. And there's only 10 marbles in total, so 6/10 is the chance of drawing a blue marble on the second draw, given that we drew a blue marble on the first draw. And now we can see the second branchings are different depending on which of the first branches we took. So whether we drew a red on the first draw or a blue on the second draw will influence what the chances are for our second draws. The chance of drawing a red is less on the second draw if we drew a red on the first draw than it would have been if we drew a blue on the first draw, because think about that, there's still 4 red marbles. So there's going to be a higher chance of drawing a red on the second draw if we drew a blue on the first draw than if we drew a red on the first draw. There'd be less reds. So that shows quite clearly the difference between independent events, where the second branches are the same, no matter which branch you took for the first branch, versus dependent events, where the second branchings are different depending on which first branch you took. And that's all we have to say about the matter. So that's it.